Quantum computers, intriguing, full of mystery, and surrounded by an aura of scientific magic. We often see images of these devices in the media, resembling the cores of futuristic spacecraft engines. Headlines proclaim that quantum computers have achieved quantum supremacy and could revolutionize the world of technology and science. But what are they really? Do they even exist? And if so, how do they work and what could we use them for? Today, we'll answer these questions and uncover the secrets of this amazing technology. How is a quantum computer different from a classical one? To understand the differences, imagine two ways of flipping a coin. For a classical computer, the result of a coin toss is either heads or tails, never both at once. A classical computer works similarly. Each bit can be either 0 or 1, predictable and unambiguous. But a quantum computer operates in a completely different way. Instead of having one clearly defined value, a qubit, the quantum equivalent of a bit, resembles more of a spinning coin. Until you stop it, it exists in a superposition, or both 0 and 1 simultaneously. This ability allows a quantum computer to perform calculations on multiple values at once, something impossible for classical computers. As Nobel laureate Richard Feynman noted, nature itself works on quantum principles. If we want to better understand its mysteries, we need machines that also rely on these principles. Quantum computers are our window into the true workings of the universe. What makes quantum computers so special? Two fundamental features distinguish quantum computers: superposition, or the ability to be in two states simultaneously, and quantum entanglement. Entanglement is one of the most intriguing phenomena in physics. Imagine two coins. If they are quantumly entangled, flipping one instantly determines the result of the other, even if they are thousands of kilometers apart. This phenomenon, which Einstein famously described as spooky action at a distance, is the foundation of quantum computers' immense potential. In 2020, scientists at Yale University developed a technology called entanglement on demand, allowing them to create entangled qubits as needed for calculations. This groundbreaking discovery could accelerate the development of more stable and functional quantum computers. If quantum computers are so powerful, why aren't we using them every day? Great question. While quantum computers are incredibly advanced, they are also very delicate. To function, they must be stored at extremely low temperatures, near absolute zero, or 273.15 degrees. In these conditions, particles become stable and can behave according to the rules of quantum mechanics. In practice, this means these machines require complex cooling equipment and special laboratories. Nobel laureate in physics, Professor David Wineland, explains, quantum computers are like ice sculptures. They need precise conditions to hold up, but their power is unmatched. We can solve problems that seemed beyond our reach, but we are only at the beginning of this journey. Can a quantum computer solve some problems faster than a classical one? Yes, and this is the most exciting part. Factoring large numbers, a task nearly impossible for classical computers with big numbers, could be done by a quantum computer in an instant. This is critical for cryptography, which relies on this difficulty. In theory, a quantum computer could break standard encryption protocols that today protect banks, government systems, and our personal data. That's why researchers are working on new encryption methods that are quantum-proof, to protect us from the potential threats this technology could bring. And what about quantum supremacy? What does it mean? Quantum supremacy refers to the moment when a quantum computer solves a problem faster than a classical one. In 2019, Google announced that its quantum computer, Sycamore, solved a problem in 200 seconds, a task that would take a classical supercomputer 10,000 years. This was a groundbreaking achievement, though it was related to a specific task that lacks everyday practical application. However, Professor Scott Aronson from the University of Texas points out, quantum supremacy is not pure magic. It's a step on the path to practical applications. It will still take some time before we can use quantum computers in everyday applications. Could quantum computers revolutionize science? Absolutely, especially in medicine. Simulations of chemical processes at the molecular level require immense computational power that classical computers cannot achieve. Quantum computers could significantly accelerate scientific discoveries by enabling rapid testing of chemical reactions and the design of new drugs. Pharmaceutical companies like Biogen are already investing in quantum technologies, hoping they will enable the discovery of drugs for neurodegenerative diseases like Alzheimer's. According to scientists, quantum computers could speed up clinical research, reducing the time and costs associated with designing new therapies. Will we all have a quantum computer in the future? That's unlikely. Quantum computers are specialized tools, ideal for solving complex, niche problems. Most of our daily tasks, like sending emails or browsing the internet, don't require such computational power. The future of quantum computers will likely involve collaboration with classical computers, where each type will be used for the tasks they perform best. Professor Seth Lloyd from MIT notes, "The full quantum revolution may take decades, but its impact on science and industry will be enormous. Imagine how our lives changed when computers came into our hands. Quantum computers will do the same for scientific research and technology." Could quantum computers help solve the climate crisis? Potentially, yes. Chemical simulations and research on new materials that absorb CO2 require immense computational power that classical computers cannot provide. Quantum computers could enable the development of more efficient energy technologies and better resource management. Professor Peter Shaw from MIT says, "Quantum computers won't solve the climate problem on their own, but they could become a key tool for scientists, allowing them to solve challenges we can't yet imagine." In conclusion, quantum computers are a technology of the future that is beginning to take shape. They could change the face of science, medicine, and industry. Although they are still in the development stage, their potential seems limitless. Thank you for joining us on this journey into the world of quantum computers. If you want to learn more about the technology of the future, subscribe to our channel and stay tuned. See you next time.